Hello everyone and welcome to the channel. God feels so weird saying that. Okay, anyways, so if you're a bioinformatics student and coding feels confusing or difficult, then this channel is for you. So in this video, we will learn the absolute basics of Python specifically for bioinformatics. So by the end of this video, you'll be able to write a Python code, work with DNA sequences, calculate GC content, count nucleotides, etc., etc., etc. Okay, so let's begin. Um, Today we will first start with understanding the variables and data types, and I'm sure you all already are aware of what a variable is and what are the different data types. So we'll just go through that very quickly, and mostly we'll focus on writing codes, some very basic codes, and as we write those codes we can explore the different operations that can be performed on data types, the different data types and variables. So let's begin. Firstly, let's see, why do we need variables? What are variables? So variables are basically nothing but containers. So variable is nothing but a named container which stores a specific value. So yeah, literally a container. Yes, you can see, as you can see here, gene name is a variable or a container which stores a value, that is BRCA1. All right, so simple, that is what a variable does. So here gene name is a variable, DNA sequence is a variable, protein name, GC content, mutation status are variables which are storing all these values. But as you can see, not all values are the same. For example, gene name, DNA sequence and protein name are all characters, so they belong to the data type called string, okay, which is an array of characters. Whereas GC content, as you can see, is a decimal, so it is a float. If it was not a decimal, it would be an integer, right? And mutation status, true, is a boolean data type. So these are the different data types, and we need to see how we can work on these different data types, because in Python you come across sequencing data, which consists of mostly strings, but you can also deal with these other data types. So we need to see how we can work around with these data types to make meaningful, to make some sense out of the data that you get, right? So let's begin. We will start with writing the code, and that's how we will slowly learn about the different concepts. All right, your code, you could use anything that suits you. You can go ahead and write it in Visual Studio or even PyCharm's good, or if you don't want any installations, you can go ahead and do that in Google Colab as well. I will write my code in Jupyter Notebook. So you select your kernel and start. What do we start with? Okay, since we just spoke about variables, we can write course is equal to, then when you print course, you get pyinfo. Okay, simple as that. So on the left hand side you have your variable, on the right hand side is the value, and this sign in between, this is not a symbol of equality. Here it represents assignment. You are assigning the value, right? So that is it, very simple. A different data type could be integer. Say you are writing length is 150. Here C, because this is Bioinfo is a string, right? It consists of characters, that is why it is enclosed in quotes. Here length is a number, an integer, so you do not need includes quotes. Same goes for float, and you can print that, and you can also perform your basic operations, like a is equal to 9, 2 is equal to 3. So you can perform your different mathematical operations. Now why is that important? Because in Python, because we often calculate sequence lengths, percentages, and statistics in bioinformatics. So that is why you need to know these basic things. I think this is too basic for someone in bioinformatics, but we're just starting off. So yeah, that's how you perform the different operations. Now we will further ahead, I would like to just focus more on strings in bioinformatics, because it is the most important section. DNA sequences, they are stored as strings in Python, and so bioinformatics, it heavily uses strings. So say I have a variable called DNA, and in that variable I am storing a sequence. Okay, this is my sequence. Okay, now first thing, I can just get that sequence printed. Okay, next important thing, if I want to find out the length of this string, I want to find out the length of the DNA sequence, then what am I supposed to do? Here I'm introducing to you the function which is called len, that returns the length in Python. So you can just write print len and DNA. So it's gonna print the length of your DNA sequence. Alright, another important thing is indexing in Python. In strings, indexing is again very important, because you have to work with sequencing data basically. And indexing in Python, it starts with 0. So if I want to say return, if I want a Python to return the first base, I have to use the index 0, right? And then if you're starting, so it's 0 1 2 3 4 5 6, and if you're starting from the other way around, then it is, you start with -1. So -1, -2, -3, that's how it works. So let's see how we can use that. So if I want to say return the first base, print what you want the first base from, where, from this sequence, and this sequence is stored as DNA. So you'll write DNA and square brackets, indexing always in square brackets, remember that, DNA 0, and close this. So it's gonna get this A. If I want, say, this T, so this T would be 0 1 2 3. So I'm gonna write 3 and print that. Okay, you could also if I write -3, I'm gonna we'll get this G, -1 -2 -3, right? Okay, another thing is you can also splice these sequences and get your desired result. So for example, this is the sequence and I just want this G T G G G to be returned. Okay, so this is 0 1 2 2, right? 2 3 4 5 6 7. Okay, I'm gonna write return 2 2 7. It's gonna return that. Why did I take 7? Because it was index 6 that it was ending at, but you need to remember this. If you write 2 is to 7, it's gonna print till 6. If you wanted just until 6, then if you wanted just until 7, you should have written 2 is to 7. Okay, that is something about indexing you need to remember. All right, so next function that I want to introduce is called count. Okay, so length function, what it does is it returns the length of the string. Now say you have this DNA sequence and I want you to give me a count of how many times A appears in the sequence, or C appears in the sequence, the frequency of each nucleotide. How are you gonna give me that? Okay, that is where this count function comes into picture. So say I want the frequency of G. Okay, so I'm gonna write print. Okay, now you need to understand and remember the use case of each of these functions. So for length, you would write len and then the name of the variable where the data is stored. But for count, you're gonna write the name of the variable first, that is DNA in this case, dot count. Okay, so count from DNA, count what? that will go inside your parenthesis. Count what? G. So you could use a single quote or double quotes and close that, close the print parenthesis, and it's gonna return the number of times G appears. Okay. Same if you want that for T, you're gonna do the same thing. DNA dot count. Count what? Count T. Close that. Okay, so that's how count works. Now let's just perform a small exercise and find out the GC content of a DNA sequence. All right, this is something which is asked a lot of times, since GC content is a parameter that is quite important. So this is our DNA sequence and you want to calculate the GC content. Okay, how are you going to do that? First, let's find out the frequency or the occurrence of G, and then let's do the same for C. Okay, let's do that and then we'll see what else to do ahead. So G is equal to, how are we going to calculate that? DNA dot count what? Count G, and then do the same for C. C is equal to DNA dot count what? Count C. Okay, now you have G and C. So to calculate the GC content, it would be, you want the GC content in a percentage, right? So how are you going to do that? First, you want GC content is the summation of G and C. So you will add G plus C, okay, divided by GC content. So GC upon the entire DNA, the length of the DNA. So GC upon the length of DNA. Okay, done. And you want this to be in a percentage, so you want to multiply this entire term, the whole term, with 100. So you just enclose this in brackets so we can multiply this whole thing with 100. Remember this, otherwise you will get a very weird percentage, and we don't want that. So multiply that entire thing with 100. G and CO. Yeah, you need to close this as well. Entire thing with 100, and you could print it. So print GC content. Okay, check the brackets again and run it. So that is your GC content. Okay, now another thing, now since we are doing this program for GC content, this is the GC content that you this is the GC content you are calculating for a sequence that you yourself have given over here, right? Say you want to what you want to do is you want to take the sequence from a user. So user gives the sequence as an input and you want to find out the GC content for that. What are you going to do for that? So there's another function for that called input. Okay, so input, it accepts user data, not just for GC content and not just for a sequence. It is something you should remember in Python. Whenever you want to accept user data, you must use input function. Okay, so it is something that is used for interactive scripts in Python. Okay, so what you're gonna do is, how do we write that? So here again I'm writing this again, DNA is equal to, you were giving the sequence over here, so at the same place you're gonna write input, and input also comes with parenthesis. Inside the parenthesis you will write whatever it is that you want to display. When the user wants to input their data, the user must see something, right? You need to give some instruction to the user. What is that instruction, or what is that message you want to give to the user? So you're gonna write enter. I'll write enter your DNA sequence. Okay, and I'll also put a colon and then I'll close that. Okay, that is the message you want to give. So done, that's the message you want to give. After that, what you're going to do after the messages has been given, then you will just do your calculation. So you could write the same code again, or you could just further simplify it one step, simplified by one step. You could calculate the G and C, thus you could sum up the G and C in one step. So DNA dot count G plus DNA dot count c. All right, gc is done. Then the same thing, gc content is equal to your gc. So gc, you'll write the name of the variable because we've already calculated it here. Then length of the dna, the input sequence. Then you're going to multiply that by 100. So close the parenthesis. I think this one is better because you don't have to then remember to close the parenthesis, and no, you don't have to make it that complex there. Into 100. Okay, then you need to print it. So this time, so if you just write print gc content, it will print the content. But if you want to, again, you're taking the input from the user, you want this to be displayed very properly to the user, then you can write it properly. You should write it properly. gc content is, okay, you write gc content is and space, close that, comma, gc content okay, and close that. So now you can see it is asking enter your dna sequence. So enter whatever sequence it is that you have. Okay, this is the sequence I'm entering, enter, and the gc content is there calculated for you. Now and this thing, however you want to display this message, you can do it. If I just want to print this, you can do it like that also. Okay, it's up to you. So this is how it is done in an interactive way. Now another thing is, see, so if you're asking the user to provide you with the sequence, what if the user writes the sequence in lowercase, in small letters? How are you gonna deal with that? I mean, you could just specify it over here that write the sequence in uppercase, but still what you could do is just you have to add one line over here. dna, you're taking the dna input, right? And then if the input is in lowercase, you just have to convert it into uppercase. So dna is equal to dna, the variable that is taking your input sequence, dna dot upper and parenthesis with that. Okay, so if the sequence is in lowercase, this will convert it into uppercase first, and then the rest of the thing will remain the same. And this is another string function that you need to remember now, upper, to convert it into uppercase. And same, if you want to convert something into lowercase, then you will write lower. Why is this important? Because here you're writing capital G, you have written G and C in uppercase. So Python is gonna look for these alphabets in uppercase. So if you do not write this and you provide something in lowercase, it's gonna give you 0. See, if I remove that and I run this and I provide a sequence in lowercase, okay, it's gonna return 0 gc content because it's looking for a G and C in uppercase, right? Now if I just add that line, dna is equal to dna dot upper, and run that, and I give the same sequence in small letters, it still is giving me a gc content. Okay, so that's how it works. So what all are the functions that we saw? We saw length, we saw count, uppercase and lowercase. All right, and also input, to take user input. Okay, now what else? Another simple thing is say you have a dna sequence. Okay, this is the dna sequence. Now you want to convert it into an RNA sequence. You are given a DNA sequence, you have to convert it into RNA sequence. Okay, what is the difference between DNA and RNA? The thymine is replaced by uracil, T is replaced by U. So that is exactly what you have to do. So DNA, and you have the sequence. Okay, this is your sequence. RNA would be DNA dot new function, string function, which is called replace. So we saw length, we saw count, upper, lower, input, and this is input is not a string function, that's just in general. Another one is replace. So in strings, you can use the function called replace, where replace comes with parenthesis. Inside the parenthesis you will write what is to be replaced. Okay, so what is to be replaced? T is to be replaced. T is to be replaced with what? Comma, and T is to be replaced with U. So U. Okay, you write your DNA sequence, you write what is to be replaced with what, and then you print it. So print, and you can write RNA sequence and comma RNA. Just run that and you have your RNA sequence. Okay, that is it. And yeah, we can also see how to work with loops. Over here I will make a separate video on that, explaining how we should be working with loops in detail. And also this is a very simple example, these are very simple codes. I will be teaching you in-depth dictionaries, lists, tuples, sets, and it is very important to understand these, how they are similar and how they are different, and then we can work on more advanced programs and codes. For now, let's just do two simple codes, one using if and for control statements. So if statement is what it is, you all know it already, it is used for decision making. So how could we use that? Say gc content, you're giving the gc content over here. Okay, so gc content say is 65. Okay, gc content is 65. Now if gc content is greater than 50, then I'll say print high gc content. Okay, if it is greater than 50. Else, now else you're not going to write else over here. Why? Because anything you write here is under the if statement. Else does not come under the if statement. It is a separate control statement. So you write else and then print what? Low gc content. And run it. I get high gc content because it is more than 50. Say I write 30, low gc content. This is just an example. You can use your real data and your real thresholds to calculate these things. Okay, next is for loop. What do we use for loop for? For loop is for iteration. It loops repeat actions, right? So because it loops repeat actions, it is very important for sequence processing. Yeah, some very important programs we could write is, say DNA again is this is your sequence. Now you want to print each base in the sequence separately. Like this is your sequence, but you want each base, this is your DNA sequence, you want each base to be printed as a separate text character. How are you going to do that? You're gonna write for base. Now base is another variable that I'm using over here because we're talking about DNA and we want this variable to parse through each of the values over here in this sequence. So I'm using base, but you could use anything. You could say write I, you could write X, whatever it is you want to write. For base in DNA, when you write for base in DNA, what are you saying? That it's gonna iterate through each of the character over here in the DNA sequence. For base in DNA, print base. So it's gonna print each of the characters, see, like this. Okay, again base is something I've written. You could write anything. For I in DNA, print I, same thing. Okay, now say you want to count the number of bases in the DNA. This as I showed earlier, you can do it using length also. Another way to do is, you have your DNA sequence. I'll do it here only. Okay, you want a count. Okay, initially, do you know the count? Do you have a count? No. So you will just initialize a variable called count as 0. So count is 0. Now for base in DNA, base is a variable, you could use anything instead of base. for base in DNA, count, so it will pass through this DNA, this variable called DNA, whatever value is stored there. If there is a base over there, then add 1 to the count, right? So count is equal to count plus 1. Okay, and then you can print the count. Again, print is not to be written over here inside the for loop. No, print is outside the for loop. So print, what is the variable? Count. So count and run that. So it's gonna print the number. I hope this is clear to you. It's just like this. See, this is the sequence. Okay, first you're initializing the count. For example, this is a sequence. If initially you are initializing the count variable as 0, it's 0 over here, right? And now so count before is 0. The variable called base is going to parse through or iterate through this DNA, and when you iterate through this DNA, initially the count is 0. We initialized it as 0. G, when it goes and it finds a base called G, it's gonna add 1. Okay, so you have 1. So the count before was 0 now, but now you have 1. So as it passes through T, the count we already have here is 1 because we already counted G. It counts T, it becomes 2. Then the initial count becomes 2. It finds A, it adds 1 to the count. Plus is equal to 1. We did it here, right? Plus is equal to 1. So it's gonna be 3. Now initial count is 3. It again finds 1, 4. It again finds 1, 5. That's the dry run basically. That's how it works. So that's how you're gonna find the count. Now say you want to, this is for you to find the count. You could do this using length also, but I ask you to find the number of each base, so the frequency of each base in this DNA sequence. How are you going to do that using count? I'll do it here. Let me also make this sequence a little longer. Okay, now say this is your sequence. Now you want to find the count for each one. What did we do earlier? We didn't have a count, so we initialized a variable called count and we gave it the value 0. Counts is equal to 0. Now we need to do that for each one because there we just wanted to find out how many bases, a count of all the bases. Here we want to find out count of A, count of T, count of G, and count of C. So we need to initialize 0 for each one, right? So counts, because we're doing it for multiple bases, I'll just name it counts is equal to, okay, and then I'll initialize A. For A it is 0, right? Then comma, the same for T. For T it is 0, comma, for G it is 0, comma, for C it is 0. Alright, initialized 0 for all. Now you want to iterate through this sequence, so you'll write for base in DNA. Okay, you're iterating through the sequence for base in DNA. If, just like earlier, if base in count, that's what we saw earlier. For base in DNA, if base in count. Again, if for base in DNA, if base in count or counts, because we've initialized counts over here, counts, then the counts of each base, you're gonna add plus 1 to it. Okay, what are we doing? We initialized each one to be 0. Again, we are passing through this for base in DNA. If the base is in count, so if any of these bases appears, then add 1 to that particular base, the value of that particular base. All right, then nothing, just print it. Print say nucleotide count, comma, what is it? Counts. Be very careful with the variable names, and then print it. So it shows us how many times each base appears. All right. Another simple thing, last code for this one. Say you have I have a normal DNA sequence and a mutated one. Okay, so that's what I'm writing over here. Normal sequence would be See, this is my normal sequence, and then I have a mutated one. I'm only initializing this. You can also take a user input. So mutated one would be mm, mm, okay, that is my mutated sequence. All right, now I want to find out at what position is it mutated. This is because I'm teaching you now. This is an example. You suppose you have, and this is a very small sequence, so you can manually also look at it and tell where the mutation has occurred. But no sequence, even for the smallest organism with the smallest genome, it's not never going to be this small, right? And it's going to be very difficult for you to sit and compare a normal and a mutated sequence with its reference and see the look for the mutation. So that's where you need to this comes in, and you need to put this to action. So you write the code for it. So you want to pass through the sequence, right? So how do we do that? We wherever there is iteration, we use for. Okay, you can write for base in normal or mutated, writing for I in. Now you need to give a range. This is again a new function that you need to remember. It's called range. You are telling this one what is the range that you have to parse through, what is the range that you that you have to iterate through. Okay, now here normally you can also give a range. Say if you had numbers over here, you could have just written ranges 1 is to 10 or 1 is to 20 or 20 is to 50, whatever it is. Here we want the range to be the length of the sequence, right? So for I in range, okay, what is the range? This entire normal sequence. So range is the length of the normal sequence. So len normal, for I in range len normal, then close the brackets. We have 2 over here, so 1 and 2, close that. Remember the semicolon. And now what are you checking? If the bases in the normal and mutated sequence at the same position, first position, second position, at the same position, if they match, good. If they do not match, then it is a mutation, and report that mutation, right? So if you're going to check, if I is the position, right, it is passing through each position. So if normal I, here like we wrote indexing, like we were giving indexing. Normal, if I had to just check for the first base, so if I would have written normal, and in the index position I would have written 0 for the first base is not equal to mutated 0, then it is a mutation. If normal 1 is not equal to mutated 1, or normal of 1, position 1 in the first sequence and normal position 1 in the second sequence is not the same, then it is a mutation. All right, but here we are checking not just for the first position, not just for the second position, we're checking for the entire sequence. So how are we going to do that? This I is passing through the entire sequence, so I is going to be there at every position. We want to check for every position. That's why here we're not writing 0 or 1 or 2 or 3. That would be a very lengthy process. Hence we're just writing I, because we know that I is iterating through it. So if normal I is not equal, this is not equal, this is assignment in Python. Equals means equality, and if you want to show not equals, then it is this. If it is not equal to, so if normal I is not equal to mutated I, mutated at the position I, okay, then what? Then again put your colon, then you need to print what you're gonna print there. Say I'm printing there is a mutation at what position? We're printing the position, right? At position and space, close that, and position would be I, because I is passing through each position. And then if I print it, so there is a mutation at position 6. Is it 1 2 3 4 5 and 0? You need to start with 0, right? 0 1 2 3 4 5 6. Yes, because there's a T over here in the normal sequence and a G in the mutated sequence, so it's reporting there is a mutation at position 6. What if there were 2 mutations? Say I change this also. This is a Yeah, there's a T over here, T and T. I'm going to change this T to say C. Okay, and then run it again. It returns two lines. There's a mutation at position 6, and then there's a mutation at position 13. So that is how you can do that. And yeah, that's it for now. I hope you found this helpful. And this was very basic, very basic. We will be practicing more programs, more codes, as we look at more complex topics. Like, first, I think I want to make it very clear the difference between lists, sets, dictionaries, tuples, all of that. Then we can look at loops and control statements. And I think we will really start writing the more complex codes once we understand what functions are. So, yeah, that's the plan. I hope you like this one and see you in the next one. Bye.